Okay, this is example 18.2 from lesson 18. We did not get to this one in class, so we're going to go over it real quick. Just so you know, this is the last thing we will do in lesson 18. We're not going to do similar triangles, so don't worry about that. So this is another ratio problem, and we're just going to see how this all works out. It's very similar to the one with the Arabian horses and the mixed breeds and the total horses and all that. So we're going to be writing three different ratios to represent three relationships in this compound. So it took 600 kilograms of sulfur to make 3,000 kilograms of a new compound. How many kilograms of other materials would be required to make 4,000 kilograms of a new compound? All right. So basically, you just have a bucket, okay? And you are going to dump some stuff into the bucket to make a new compound. I'm not very good at drawing. All right. So you're going to dump in some sulfur, and you're going to dump in some other stuff. So S, I'm going to call my kilograms of sulfur, and the other stuff I'm going to call X kilograms of some other stuff. And then you'll have a total number of kilograms in the bucket. It'll be the number of kilograms of sulfur plus the number of kilograms of other stuff gives you the total kilograms of the compound. So this is what's happening here. We're making a compound. Try to understand what is going on instead of just looking at your book and shoving some numbers in for some letters and stuff. Okay. Your book, instead of using X for the other stuff in the compound that they don't tell us what it is, so other materials, your book uses NS, meaning not sulfur. I do not want you to use this notation because when you write two letters, both the same size like this looks like two variables. N times S is what this looks like. So we will not use that notation. All right. So X will be our other materials. S is our sulfur, and T is the total number of kilograms in the compound, the new compound that we're making. Okay. So these are the relationships. It takes 600 kilograms of sulfur to make 3,000 kilograms of the new compound. So my relationship between sulfur and the total number of kilograms in the compound is 600 to 3,000. That's what the first sentence tells me. I can take this ratio and write this proportion and write two other proportions. I can talk about the ratio of other stuff to the total. All right. If the total is 3,000 kilograms and there were 600 of those were sulfur, then that means the rest of them were something else, X, and that will be 3,000 minus 600 or 2,400 kilograms of other stuff. So that gives us two proportions, and then the other proportion is going to be the ratio of sulfur to other stuff. All right. So sulfur, that was 600 kilograms, and then other stuff was 2,400 kilograms. So I've written three different proportions just based on the first sentence of this problem, right? And that's what you want to do. You want to write three proportions just using the initial information they give you, the relationships between sulfur, total compound, and other materials. So those three relationships. Now we're going to use one of those relationships to solve the problem because we're going to read the question. How many kilograms of other materials would be required to make 4,000 kilograms of the new compound? So this question involves other materials, that's the X, and new compound, which is the T. But they're telling us 4,000 kilograms of the new compound. So the two things we're looking at, other materials, which is X, and the new compound, which is T. That means we're going to use this proportion right here. So X, we don't know. We still don't know what that is. How many other materials? So that's missing. T, 4,000 kilograms of the new compound is what we're trying to make. And we know that according to this proportion, that should be 2,400 over 3,000. That's supposed to be the relationship between other stuff and total. All right. So we are going to solve for X to find out how many kilograms of other materials would be required to make 4,000 kilograms of the new compound. Before I start doing anything, I'm going to get rid of some of these zeros. I can reduce this fraction on the right side by knocking off a couple of zeros there. And then I could even, if I leave this like this, I could even go ahead and reduce that right side even more. 6 goes into 24 4 times, and 6 goes into 35 times. Now I'm going to use cross product. 5 times X has to be equal to 4 times 4,000. All right, so 5X is equal to 16,000. And then if I divide both sides by 5, I am going to get 3,200 kilograms of other stuff.